Lines. Today's topic is lines. You guys have probably heard of lines before, but we're going to go over this for you. Your typical equation of a line is given to you by y is equal to mx plus b. You guys recognize that from somewhere? There's two very important things here besides, of course, the independent variable x and the dependent variable y. We have the m. The m is going to be the slope of the line. And the b, and that's the y-intercept of the line. Y-intercept, what does that mean? It would be really helpful for me if I had a picture of this line, then I could talk about its intercepts. Okay, so here we're going to have the graph, and remember the x-axis is there, the y-axis is there, and let's just draw a line that we can work with. Let's say our line is like this. Okay, so this line is going to have a given equation, y is equal to mx plus b. The m is the slope, so how fast or slow it's going up, or if m is negative, it'll be going down. And then the b, the y-intercept, is actually right here. It's the place where the line intercepts the y-axis, okay? So right here, this is where the value of b is located. That's because that's the y-intercept. And then besides the y-intercept, there's another intercept that's called the x-intercept, and that's the place where the graph intersects the x-axis right here. So you can see it hits the x-axis at this point right here, so we're going to call this the x-intercept. Okay? Now the y-intercept is easy to see from the form of the equation right here. It's going to be the b, and please note that if you plug in the value of x, x equals 0, what do you get? Y equals m times 0, y equals b. So there you go. You can interpret it as the place where you plug in the value x equals 0. Okay? But what about the x-intercept over here? That's actually the place where the height is equal to 0. So this is the place where the y value is equal to 0. That's the x-intercept. Okay? So to give that to you algebraically, the x-intercept is the place where y is equal to 0. So if we put that into the y equals mx plus b equation, y equals mx plus b, that's equal to 0. Solve that out for x. We're going to get x is equal to negative b over m. Okay, you can check that yourself. So this is the value of x such that we're located at the x-intercept right there. Okay, so just as points, if you'd like to see these two things written as points, I'll erase this right here and give it to you in the XY format as points. Remember, this is the place right here where x equals 0 and y equals b. Okay, this is the place where b is equal to minus b over m. That's what we just solved out for. And then the y is equal to 0. Okay, so those are the points in that format you can see there. Let's talk a little bit about the meaning of slope, because the slope is going to be very important to our concept of line here. Meaning of slope. You guys have probably heard this before, that the slope is equal to the rise over the run. Maybe you've had to sing that to yourself before. That slope is rise over run. What does that really mean? Well, the rise refers to the change in the y, and the run refers to the change in the x. Okay, so the rise is the change in y, and the run, that's going to be the change in x. And if I go back to the picture over here, when you say the word run, you kind of think of yourself walking along the x-axis. How far did you go over if you started running? However far you went over, now you want to measure how far correspondingly you went up. So the difference in the y, that's the rise, that's what goes on the top of the fraction. And the difference in the x, how far did you go over, that goes on the bottom of the fraction when you're calculating the slope. Okay, so let me give you an example here. Before we go into an example, I'll just go over the meaning of slope a little bit more by drawing you a couple pictures. I'm going to draw you 3 pictures, and what I'd be looking for in these pictures is, what is the sign of m, the slope? And by sign there, I mean, like, is it positive or negative or 0? I'll draw you 3 pictures like this, and then you let me know what you think. Pause the video and see if you can figure out the sign, positive, negative, or zero, of all three of these black lines here. Okay, so when we're looking at the sign, we consider if we go over a positive amount, what is the change in the rise? If the run, let's say, is 1, let's say I go from the number 1 and then I go over to the number 2, I went over by a run of 1, so there will be a number 1 on the bottom there. What happened to the rise in this case? I went from a higher spot to a lower spot. So that means I went down, so that means it's negative. So the answer for this is the slope of this one is m is less than 0. It went down. Okay, let's go over to this one. Let's say I'm at the number 1. I go over to the number 2. In this case of a horizontal, completely flat line right here, I went over 1. How much did my rise change? None at all. That's right, 0. So this is a case where m is equal to 0. And then the final case here, if you did it again, you can see that if you went over from 1 to 2, you actually increase in your rise, and so therefore the m would be greater than 0. Okay, so take a look at these three lines here, and make sure that you can at least recognize the sign of the slope just from the way that the line looks. That way, if you're calculating it later, you can check your work. At least you know you're on the right track if you can visualize the correct sign. Okay, so now we'll go into an example of how to calculate the equation of a line given 2 points. And this is a very common problem that you're going to run into. Actually, this is very useful in real life. Say you're running a business, you have one observation, then you have another observation. The easiest way to create a mathematical model is going to be to draw a straight line between your 2 points of observation. And then you're going to use that line to interpolate or make predictions about your future data. Okay, so this is very important for you, finding the equation of the line given 2 points. And we've got 2 points right here for my example, 1, 3, and the other point is going to be 3, 7. Can you find the equation of a line? If you feel like you're already there, go ahead, you can pause the video right now and find this equation given these 2 points, and then you can make sure that you got it right. Okay, so how I'm going to do it, before I even begin to do the algebra of it, is I would really like to draw a picture of this, and that way I can make sure I'm on the right track, see if this is a line going up, a line going down, is it flat? Let's see, the first point is 1, and then I go up to a height of 3 right there. The second point is 3, and then I went all the way up to a height of 7. The other point's right there, so I'll just use this other color in black. And it looks like my line is going to go like this. Okay, so I didn't draw it perfectly straight, but you get the point. What do you think the value of m is going to be in its sign? You think it's positive, negative, 0? That's right, it's going to be positive because it's going up like this. And so what I'm going to do is now calculate that algebraically using the meaning of slope to say rise over run. Okay, when you're given 2 points and you're asked to find this equation, I hope that you don't feel like you need to fumble around in your notes to try to find some formula to help you do it. It would be best if you could just understand what you need to do and why. Okay, so what you need to do is find how far over did I run, put that on the bottom. How far up did I rise? You put that on the top, and m is going to be simply your rise over your run. Okay, so how far over did I go? I went from 1 to 3, so the difference that I'm going to put on the bottom is 3 minus 1. I went over by 2. How far up did I go? Well, I went from 3 and went all the way up to 7. So I'm going to say 7 minus 3, and that's going to be 4. So my slope here is 4 over 2, which simplifies down to just 2. And you see I got a positive 2, and that confirms what I thought because I saw that the line was going up. Okay, so that's great. I've already got m, but you can see that in this equation, y equals mx plus b, I actually need 2 things. I need the m, and I need the b. And inside a problem like this, given 2 points, you always want to find the m first. Okay, so finding the m, that's going to be your step number 1. And once you have the m in place, then step number 2 is going to be to solve out for b. And how you do that is you choose one of these points. You don't need them both, but I'll use them both to show you that you get the same answer no matter which one you pick. And you need your answer from step number 1. You need the m that you just found. That's why you go and get that first. Okay, so I'll just use this first point. I'm going to use the point 1, 3. Okay, and now when I use this point, I have to recognize which is the value for x and which is the value for y. Every point is always written in its x, y format. So the value for y is 3, so I'm just going to plug that into the form of the equation there. It says 3 equals, and then that's why I need my answer from step number 1. The next thing it asks for is m. Good thing I just found that. That's 2. The value for x is found right here from the point. The value for x is the number 1. And the final component is the b. That's what I'm trying to find out. I don't know what it is. So I have the answer 3 equals 2 plus b. So what value should b be to make this statement true? B is equal to 1. And remember that graphical interpretation of the value of b is the place where this line will intersect the y-axis. And you can see that's another reason why I started the problem by drawing a picture of it, just a rough sketch, because that confirms the answer that I got. The b equals 1. It looks like that's exactly where the black line hits the green axis, the y-axis right there. Okay? Just to double check so you believe me, you can use either one of the points. I used 1, 3, but let me do it again where I'm going to use 3, 7. And just like before, the y value goes on the left-hand side, then the slope comes in and gets multiplied by the x value, and then you have to add your unknown b, and now you see I've got the equation 7 equals 6 plus what? What's going to make that true? Same thing, b equals 1. You only have to do it once. If you have extra time and you're in an exam setting, you may want to do it twice just to make sure, and you'd also love to have this picture handy so you can check your work. So I have found the equation of the line, and I want to give it in my final answer here. Given these 2 points, the equation of the line is, red and black right here, y equals 2x plus 1. Okay, so take a good look at where I inserted the m value 2 and the 1 value for b, and there you go. You may also encounter a problem where they've given you not 2 points, but they've given you 1 single point, and then they've given you a value for m, the slope. That type of problem is a little bit easier because you can consider it just like this, but you've already gone through step 1. You've already found the m if they've given you the m, and then if they give you just 1 point, you can see that in step 2, all I really need is 1 point, so then you would just have to do step 2, and then you would obtain the equation of the line. It's going to be very, very handy for us to understand linear functions in general and be able to obtain the equation of a line given 2 points or given 1 point and then the slope of the line. So let me go into a couple applications here, and we're going to see many, many forms of application of linear functions in business and in other places. M, the slope, is usually a rate. So I'll say m, which is the slope, is usually a rate, some kind of rate. And so what I mean by that is the units are usually a fractional type of unit. The units, for example, could be dollars per hour. How much are you getting paid? Dollars per hour. Miles per gallon. Dollars per month, how much money you're making dollars per month, etc. You see that each one of these units that I've written for m is a fraction. It has one type of unit on the top and a different type on the bottom, and because m is the rise over run, the rise corresponds to y, so the units on the top are always the units of the y variable. The run is on the bottom, so the units on the bottom are always the units of the x variable. Okay, so if I had a slope and I knew that it was in dollars per hour, I would know that the units on the x is hours and the units on the y is dollars. Here, the x variable has the units of gallon, and then the y variable has the units of mile. So m is usually seen as a rate that way in application. And let me go into an example here and see if you can pick out the units and the value for the slope. Okay? Let's say that I want to get a phone. I want to get a little cell phone here, and the cell phone company is going to charge me some sort of flat rate just for having the phone in general, and then it's also going to charge me by the minute for how many minutes I use. Okay? So let's say a phone company has monthly flat rate. That flat rate, you have to pay it no matter what, even if you don't use the phone. That's going to be $10. And then the per minute rate is maybe just 5 cents per minute. Okay? What I want you to do is form an equation for the monthly charge as a function of the minutes used and I'll just tell you right now that the answer is going to be in the form y equals mx plus b. This is going to be a linear model. So x is the independent variable. That's going to be in the units of minutes used. Y is the dependent variable. That's going to be in units of dollars for the monthly charge. And the m and the b are hidden inside this setup somewhere. So pause it right now and see if you can figure out the answer I'm looking for right here in this form. Okay? So let's see. We really only have two numbers here. We're going to use the letters x and y for the variables. So it's basically where should I put the 10 and where should I put the 0.05. And if you remember what I just said about the units on a slope are usually something per something. This one, $10, is just dollars. It has actually the same units as the y, because the y is the charge in dollars. This one has units of dollars per minute. And so that's the one that's going to be the slope. You see, the y variable has units of dollars, and the x variable has units of minutes as a function of minutes used. That's how I figured that out. So the x variable has minutes there. So the answer is going to be y is equal to the rate per minute times how many minutes used plus the flat rate of $10. Okay? So usually in a question like this, I might say interpret the slope, but we've already interpreted it here. That's the per minute rate. Now let's interpret the y-intercept. Can you guys see the y-intercept and interpret it for me? That's right, the y-intercept is located right here, 10, and it interprets as the amount of money you have to pay per month, even if you don't make any minutes on your phone calls. So yeah, there you go. Let's have another one here, where we have a salesman, another example. A salesman gets paid not only a flat rate for showing up to work that day, but he also gets paid a little bit extra for every sale he makes. So let's say a salesman's daily pay is $30 just for coming in, plus $5 for each sale. Okay? So again, this is going to turn into a linear model. I'll be interested to know how much is that salesman going to make as a function of the number of sales he makes. See if you can get that one. I want you to write in y equals mx plus b format the amount of money he makes, equation for the daily income as a function of the number of sales that he makes. Go ahead and pause that video and try to write down the equation. Okay, so the answer there is, again, we have to recognize what's the m and what's the b. And you can see here the m should have some sort of fractional rate, dollars for each sale. So it's hidden here. I didn't say per. I didn't write the fraction, but really, if I did want to write it as a fraction, $5 per sale. Okay? And you can see that the x, the independent variable, as a function of sales. So the X unit is on the bottom, and the Y is going to be daily income, so that's in dollars, and the Y unit is on the top there. So this is the slope, and then the other one's going to be the Y-intercept. So we have 5x plus 30. And when you're doing a problem like this, don't forget that once you find the slope, you must multiply the slope by the x, and then you just add the y-intercept right there. Okay.